righty. Well, this is getting a little hairy. This is an alternating series. Is it an alternating series? It is. We have the little alternating device here. One, when I substitute it, is actually going to give me 2 as my exponent. So this is going to be a positive term to start with. And then I would plug in 1, 1, 1 all over the place and evaluate that. And then substitute the next value, 2. 2 plus 1 is 3. That would give me a negative. And then substitute 3, 3, 3, and that would give me the term, and so on and so forth. Okay, so it is alternating. If I take the limit as n approaches infinity of n plus 5 over n plus 2 times n plus 3, does that equal 0? Well, yes, because if I were to multiply the denominator, the biggest term would be n squared. So that would mean the denominator is getting bigger faster than the numerator. So this is going to 0. Check. But now, how do I show that this is decreasing? Well, I could use one of these manipulated uh, expressions to show that it does decrease, right? And I think I'm going to use this one. So let's find a sub n plus 1. Let's change colors. Let's find a sub n plus 1. A sub n plus 1 means I'm substituting n plus 1 wherever you see a variable n. So n plus 1 plus 2 plus, multiplied times n plus 1 plus 3. Now, if I simplify this, that's n plus 6 times n plus 3 times n plus 4. Okay, so the setup said if we take the ratio of the n plus 1th term divided by the nth term, if it's less than or equal to 1, then that shows that it is decreasing because it comes from the definition of decreasing. Okay, so I'm going to take this a sub n plus 1, and I'm going to divide it by a sub n. So that means that we have, let me change this color. That means we have this fraction. Let me use the original purple here. N plus 6 over n plus 3 times n plus 4 divided by a sub n, but let's just multiply by the reciprocal. The reciprocal is n plus 2 times n plus 3 divided by n plus 5. And I get something that looks like this. Okie dokie. Now, how do I show that this is actually... Is there anything that I can... Oh, look, I can cancel. I can reduce the n plus 3s. Oh, that's nice. So now what am I left with? Well, I'm left with n plus 6 times n plus 2 times n plus 4 times n plus 5. Is that less than or equal to 1? Because that would show that it is decreasing. Well, here we're going to use some algebraic manipulation that you might find pretty neat. We're going to go ahead and multiply this out. So if you multiply this out, we're going to get n squared plus 8n plus 12, right? If you distribute and multiply every term in the first times every term in the second, we get this. Divided by, and we're going to do the same thing here. So n squared plus 4n plus 5n, so that's going to give me 9n plus 20. Can I see that the denominator is bigger than the numerator? Well, yes, because I notice the numerator has an n squared, the bottom has an n squared, but the denominator has bigger terms than the numerator, right? Like 9n is bigger than 8n and 20 is bigger than 12. But if you want to cement that idea, we can even do this. Like this should tell you, oh, this is a fraction that's less than 1. Like that should be enough. But if you're still not convinced, what would happen if instead of writing 9n, I would say 8n plus another n? That would be 9n, right? And what would happen instead of writing 20, I would say that's 12 plus 8. Because if I close this off, hey, look, This is the exact same thing as the numerator. Oh, but the denominator has extra, so therefore the denominator is larger than the numerator, and it is less than 1. And therefore, it is decreasing. And if it's decreasing, we just show that this alternating series converges. The limit has to equal 0, and then I have to show somehow that the function, not the function, the series terms are decreasing, and it is. Okie dokie. I want to look at number 4. Number 4 is really interesting. And I know some people might look at this and start to panic at the trig presence. But think about what this is. We substitute 1 in here. We're going to take cosine of pi. Cosine of pi is -1 times, and I'm going to substitute 1 here. 1 times 1 is 1. Oh, so this is just -1. Plus, substitute 2. 2 would be 2 pi. Cosine of 2 pi, that's +1. And when I substitute 2 in here, that's 1/2. Oh, look at this. Plus, substitute 3. That would be cosine of 3 pi. That's -1 times 1 over 3. So that's -1/3. Plus 1/4 plus -1/5 plus yada, yada, yada. This is the alternating harmonic. This is the exact same series as this one. But notice the alternating device, I call it the device, the alternating device is different. It's not -1 to the n, as it is over here. It's the cosine of n pi. So this is an alternating harmonic. We already know that the limit does go to 0. We already know that the sequence terms are decreasing. So I can say that this converges by alternating series test. All right. Let's pause this video. We'll come back and we'll finish off alternating series. And that'll be the end of our first part of Unit 10.